It's the year 2050. You're standing on the red, rocky surface of Mars, a strange and dusty world, with a pale sun casting a faint pinkish glow over everything. Beside you is a high-tech companion, not human, but an artificial intelligence guiding you through every step you take on this distant planet. Think about it. This machine is more than a tool. It's a guide, a protector, and a problem solver. It knows the terrain better than any human could, it monitors the weather to warn you of dust storms, and it's even scanning the ground for water or minerals, feeding you crucial data in real time. We're talking about a level of intelligence that's already changing how we explore space. In fact, right now, as you're watching this, there are AI systems scattered across our solar system, exploring, mapping, analyzing, and making decisions in real time. They're in places we've never set foot on, and they're there not just to assist us but to learn on their own and adapt. But how did we get here? How did artificial intelligence go from being a concept in science fiction to an essential partner in our journey to the stars? It's an incredible story, one that starts back in the days of the first space missions, where we weren't even thinking about AI as we know it today. Back in the 1960s and 70s, space missions were entirely controlled by humans back on Earth. Every decision, every maneuver, every problem had to be solved by the people in the control room, sometimes through radio signals that took minutes to travel across space. The limitations were obvious, but back then, no one imagined sending a robot to explore on its own. As we ventured farther, the need for something smarter, something more adaptable became crystal clear. That's where artificial intelligence started coming into play. Not in the way we use it today, but in small, calculated steps. Little by little, AI technology began to make its way into space exploration. With rovers like Spirit, Opportunity, and later Curiosity, NASA started pushing the boundaries. Think about Spirit and Opportunity, the two rovers sent to Mars in 2004. They were designed to last only 90 days, but thanks to advancements in machine learning, they adapted and ended up working for years, sending back invaluable data. What made these rovers special wasn't just their resilience, it was their ability to make certain decisions independently. If they encountered an obstacle, they could analyze their surroundings and find an alternative path without needing to ask for permission from Earth. That was the turning point. It was a glimpse into what AI could do for us in the future, how it could extend our reach into the stars. And it wasn't just about helping rovers find their way. Scientists began to see AI as a way to accelerate our search for answers across the universe. With AI, we were able to handle unimaginable amounts of data streaming from space. The AI-driven algorithms could sift through this data at incredible speeds, discovering things humans would never spot on their own. It helped us identify thousands of exoplanets, distant stars, and even strange cosmic phenomena. And as AI advanced, so did our confidence in its potential. So, today, artificial intelligence isn't just a handy tool, it's the partner we never knew we needed in space exploration. From autonomous space probes traveling beyond our solar system, to robots on Mars preparing the way for human arrival, AI is transforming the very nature of exploration. It's paving the way for humanity to not only dream, but to actually reach beyond what was once thought possible. But this is just the beginning. We're entering an era where AI will take on even bigger challenges. Imagine missions to planets beyond Mars, where it's not feasible for humans to travel, or at least not yet. AI will be the scout, the pioneer, venturing into the unknown and sending back knowledge. So, here we are, standing at the edge of one of the greatest shifts in space exploration. One where artificial intelligence isn't just a tool, it's becoming a driving force. But how exactly is AI powering these new discoveries, and what can it really do in space? Take Perseverance, for example, the latest Mars rover equipped with cutting-edge AI technology. It's not just collecting rock samples, it's making its own choices about what's worth studying, where to drill, and how to avoid obstacles. And these decisions, they're all happening in real time, right there on Mars. Now, why is this autonomy so crucial? Well, imagine this. Mars is, on average, 225 million kilometers away from Earth. A signal takes anywhere from 5 to 20 minutes to travel each way. That delay means if something goes wrong, the rover has to think on its own, adapt, and sometimes even save itself. This isn't just about saving time, it's about survival. The AI on Perseverance processes images, analyzes the terrain, and selects the safest path forward. And when it finds something interesting, it has the ability to prioritize and take closer looks at specific rocks or soil samples, something that would be impossible without real-time decision-making. But what's even more impressive? Perseverance doesn't just send us pretty pictures, it's feeding back valuable data that helps scientists here on Earth understand Mars in ways we've never imagined. This is AI going beyond just navigation, it's conducting research, exploring actively. We're learning about ancient Martian rivers, possible signs of microbial life, and even testing oxygen production. And the AI is right in the middle of it all, working as our remote scientist. And while Perseverance is busy on Mars, AI back here on Earth is revolutionizing how we explore the skies. Ever wonder how we manage to track so many distant galaxies, stars, and even exoplanets? With telescopes gathering immense amounts of data every second, there's simply too much information for human eyes to handle. These AI-powered simulations help scientists visualize how galaxies are formed, how stars live and die, and how massive cosmic events unfold. With AI, we can now predict the future behavior of stars, the dynamics of planets, and even model entire galaxies. This is as close as we've ever come to creating a virtual universe, a sandbox where we can test our theories about the cosmos. Imagine this for a second. AI can now simulate the conditions for life. By examining what we know about Earth's evolution and applying it to planets we've never seen, AI can help scientists predict where life might exist beyond our planet. We're getting closer to understanding the conditions that could make distant worlds habitable. This Goldilocks zone, not too hot, not too cold, is a sweet spot around stars where conditions might allow liquid water, a key ingredient for life. Thanks to AI, we're scanning for these zones more efficiently than ever, and we're finding them in places we once thought impossible. All of a sudden, the idea of finding life beyond Earth doesn't seem so far-fetched. And speaking of venturing further, AI isn't just focused on Mars or telescopes from Earth. AI-controlled spacecraft are now traveling further than we ever could on our own, diving into the depths of space, observing asteroids, moons, and even venturing toward the Kuiper Belt on the fringes of our solar system. Take New Horizons, for instance. After its incredible flyby of Pluto, this spacecraft continued into the Kuiper Belt, scanning objects billions of kilometers from the Sun. Even with the immense distance, New Horizons' onboard systems, enhanced with AI, allow it to select interesting targets, analyze their characteristics, and send data back to Earth, all while conserving energy for its long journey. Think about it. AI isn't just expanding our reach across space, it's shaping what we know, how we imagine, and where we're able to go. Without it, our exploration would be so limited, restricted to the closest planets and a fraction of the stars we've set our sights on. And here's the truly amazing part. AI is evolving every day. With each mission, each discovery, and each bit of new data, AI learns more and becomes an even more powerful force. We're not just programming it. In some ways, it's beginning to program itself, learning from experiences and refining its own capabilities. Alright, so we've seen how AI has already transformed our understanding of space, guiding rovers across Mars and helping us spot distant exoplanets. But what's next? Where does AI go from here as we push further into the cosmos? Let's start with something ambitious: deep space travel. We're talking about places so far away that even the nearest star, Proxima Centauri, is over 4 light-years from Earth. At our current speeds, it would take thousands of years to get there. But imagine if we had AI-powered spacecraft, smart enough to travel autonomously for decades, maybe even centuries. Think of it like a cosmic navigator, constantly learning from its surroundings, recalculating its path to dodge obstacles, and conserving fuel for the long haul. These AI systems would need to be adaptive, able to learn and solve problems in real time, without any help from Earth. Once they're launched, they're on their own. Scientists and engineers are already developing these autonomous AI systems. They call it reinforcement learning, where the AI teaches itself the best ways to tackle new challenges by simulating them again and again. Imagine sending a probe on a one-way journey to an unknown star system. With reinforcement learning, it could adapt to anything from unexpected gravitational forces to asteroid fields it wasn't programmed to handle. This kind of self-learning AI would be like giving a spacecraft its own intuition. It might encounter a new planet and decide to slow down, take measurements, or even deploy a drone for closer observation. In essence, these AI systems would operate like explorers on autopilot, capable of making choices, adapting, and who knows, maybe even making discoveries that surprise us all. Imagine this. These probes could reach unexplored star systems and discover planets completely different from anything we've seen before. AI wouldn't just snap a photo and move on, it would be analyzing the atmosphere, scanning for signs of water, and studying temperature variations. And as it learns more, it could communicate findings to other probes, creating an interconnected web of AI explorers across the galaxy. And speaking of distant worlds, AI is poised to be our best partner in the search for life. Imagine AI-powered labs floating through space or stationed on Mars, able to test samples right there without waiting to send them back to Earth. These labs could scan for microbial life or analyze soil samples for signs of organic compounds. Why does this matter? Because waiting for samples to travel millions of kilometers back to Earth could take years, but an AI lab could deliver results in hours, maybe even minutes. Imagine knowing within days whether a distant moon like Europa or Enceladus has signs of microbial life beneath its icy crust. Take Europa, for instance, one of Jupiter's moons, with a thick layer of ice that scientists believe hides a vast ocean underneath. Getting to that ocean is a major challenge. But with AI-powered drones or submarines, we could have machines capable of drilling through kilometers of ice, scanning the waters, and even hunting for signs of life, all on their own. And let's not forget about one of the biggest ambitions of all, establishing human habitats on other planets. This is where AI becomes essential. Imagine setting up a colony on Mars. We'd need AI to monitor and manage almost everything: temperature, food supplies, oxygen levels, and even structural safety. AI would also play a critical role in handling emergencies. Imagine an unexpected dust storm threatening the colony. The AI could instantly seal off sensitive areas, reroute power to backup systems, and alert the inhabitants to take shelter. It could even handle medical emergencies, diagnosing illnesses, managing supplies, and assisting remote doctors from Earth. And here's where things get even more fascinating. With AI managing colonies on different planets, we're looking at the possibility of interconnected settlements, each one part of a larger network that could span Mars, the Moon, and beyond. This isn't just space exploration, this is laying the groundwork for a new civilization among the stars, supported by intelligent systems that make life possible. Let's talk about the concept of interstellar travel. Traveling to distant star systems isn't just about speed, it's about survival. If we're going to send humans or even advanced probes on these multi-decade or multi-century missions, we need AI systems that are not just intelligent but almost self-sufficient. For a mission of this magnitude, AI would have to take on roles we've barely scratched the surface of. It wouldn't just be piloting a spacecraft, it would be managing resources, monitoring radiation, adjusting life support, and even making real-time decisions on the fly. And here's the kicker, it would need to handle all of this with no human input for years, maybe even centuries. Imagine a vessel flying light years from Earth and suddenly, it hits an unexpected meteor shower. No one's there to give instructions. This is where AI's autonomous decision-making comes in. It would need to analyze the situation, reroute the vessel, repair any damages, and even develop new strategies if it faces repeated threats. This is beyond programming, it's a level of resilience and adaptability we're still working toward. We're talking about AI systems capable of self-repair and self-optimization, like a spacecraft that knows how to fix itself in case of damage, can upgrade its own software to adapt to unforeseen challenges, and can even modify its path if it detects obstacles. These spacecraft would almost have an identity of their own, as they learn and evolve from each challenge. Back here on Earth, scientists are testing the durability of AI systems, simulating the intense conditions they'd face in deep space: radiation, micrometeoroid impacts, extreme temperatures, you name it, they're preparing for it. Because for a mission that could last hundreds of years, they need an AI that can keep going no matter what. One of the biggest challenges? Radiation. In the vastness of space, there's no protective atmosphere to block cosmic rays and solar radiation. This is especially dangerous for electronics, and AI systems are no exception. So researchers are developing radiation-hardened AI, systems that can function under intense radiation without losing their memory, processing power, or functionality. Essentially, these systems would be wrapped in special shielding and built with redundant components, so if one part fails, another can take over instantly. It's like building a shielded fortress around the AI brain of these spacecraft, making sure they're protected from the harsh realities of space. And then there's the question of exploration itself. AI wouldn't just be a passenger on these journeys, it would be an active explorer, a cosmic cartographer mapping new star systems as it goes. Let's say an AI-powered probe reaches an uncharted planetary system. It would be capable of cataloging everything it finds, identifying planets, moons, asteroid belts, and relaying that data back to us. Imagine the richness of the data it could collect: atmospheres, gravitational fields, potential water sources, geological formations. It could send back virtual maps of entire star systems, complete with information on temperatures, radiation levels, even potential habitability scores. It's like having a robotic interstellar scout that tells us what's out there light years away. And while these systems gather data, they wouldn't be completely disconnected from each other. Picture this: a network of AI explorers, each in a different part of the galaxy, sharing data and learning from one another. One probe encounters a gravitational anomaly, it logs that data, and the next probe that encounters something similar is already equipped with that knowledge. This interstellar knowledge network could evolve to be our bridge to the unknown. With each mission, each new bit of information, these AI systems could build a repository of knowledge on the cosmos, guiding future missions, refining our understanding, and essentially expanding our reach across the stars. And if, one day, we want to send humans to settle these distant worlds, AI would have already paved the way. AI systems could set up habitats, test for life-supporting conditions, and create environments where humans could thrive. Think of it as AI laying out a galactic welcome mat, preparing these worlds for us even before we arrive. AI-driven systems would establish everything from energy grids to agricultural setups, creating sustainable colonies. So when humans do get there, they're stepping into a ready-made ecosystem, with AI handling day-to-day logistics, maintenance, and resource management. It would be like showing up to a new world with a fully built city, thanks to our AI pioneers. The vision here is profound. AI isn't just a tool or a machine in this future, it's our first contact with the unknown, our vanguard on the path to new worlds. And by setting up this infrastructure, AI becomes the foundation upon which we can truly become a multi-planetary species. As we push into these realms, AI transforms from a system into a companion, a partner in our journey through the universe, a guide for our species as we take the most daring steps in human history. This isn't just science fiction anymore. It's the future that AI is helping us create, one mission at a time. Alright, so we've now entered these distant worlds, established colonies with the help of AI, and set up self-sustaining systems. But here's a question that's bound to come up. How do we maintain and protect these colonies? Because as we know, even the best laid plans need ongoing oversight. On Earth, we have entire cities, governments, and intricate systems to handle the constant demands of daily life. But imagine an outpost millions of miles away, where a breakdown in the water supply or a glitch in the air filtration system could be a matter of life and death. For these colonies to survive, they'd need to be practically self-sustaining, and that's where AI will come into play, keeping everything running, from life support to logistics. These AIs wouldn't just be fixing problems as they arise, they'd be constantly monitoring every system, preempting issues before they happen, running simulations and making adjustments. Think of it like a 24/7, fully autonomous mission control center that's not just reacting, but proactively ensuring every component is in optimal condition. But beyond just maintenance, what about the big picture? Suppose this colony encounters unexpected challenges like extreme dust storms, radiation spikes, or even the need for a quick evacuation. These AIs will need to go beyond basic programming. They'll have to make high-stakes decisions, like rerouting power, sealing off areas, or coordinating evacuation protocols for the safety of everyone there. In these life-and-death situations, AI becomes the first line of defense. And not just that, it acts fast, adapting plans and using advanced simulations to respond in real time. Imagine the complexity of the calculations it has to perform, factoring in hundreds of variables at once to choose the best course of action. It's a skill set beyond simple automation. It's almost like a form of judgment. So back on Earth, scientists and engineers are putting AI through the toughest tests imaginable. They're throwing all sorts of simulated disasters its way to see how well it adapts, learns, and ensures the colony's survival. Because in space, there's no second chance, and these systems need to be ironclad. And then there's another challenge, the idea of expansion. As our understanding of these planets grows, AI would need to construct new habitats, research facilities, even new cities. Picture a self-expanding colony, where AI-powered robots build structures piece by piece, adapting to the environment and following blueprints that it creates on its own. This isn't just futuristic fantasy, it's something already in development today. We have 3D printing robots, for instance, capable of constructing small structures, and they're evolving rapidly. In the future, AI could manage entire fleets of these machines, turning barren landscapes into thriving outposts, one building at a time. Imagine an AI-driven greenhouse where crops are grown, harvested, and distributed without human intervention. AI systems would monitor soil health, adjust water and nutrient levels, and even select the best crops for that environment. And this isn't just for survival. These systems could eventually lead to self-sustaining food production, creating not only edible crops, but even medicines and biomaterials for building. Back on Earth, researchers are already testing hydroponics and gene-edited crops that could one day grow on Mars or the Moon, and AI is leading the charge. It's optimizing conditions, selecting strains that can handle low-light environments, and experimenting with ways to boost yield. Because a thriving colony isn't just about surviving, it's about creating a sustainable ecosystem that can truly support human life. And it's not just about what the AI does on site. The data collected from these colonies would be sent back to Earth, where it's analyzed, refined, and fed back into the algorithms running these outposts. In a sense, we'd have a feedback loop between Earth and these colonies, continuously improving how AI supports human life in space. This communication bridge between our planet and these distant worlds would be key. AI would be constantly learning from every situation, every environmental shift, adapting its systems in real time based on what's being learned both there and here on Earth. In essence, these AI systems would not only support life, they'd enable a whole new way of living. From ensuring basic needs like food and water to maintaining safety and even expanding the colony's infrastructure, AI would be a part of every aspect of daily life. And as these colonies grow, we can imagine a future where AI-driven societies extend across different planets and moons. These societies wouldn't be bound by traditional earthly limitations. They'd be constantly adapting, self-sustaining, and capable of evolving in ways we're just beginning to understand. So we've set up our colonies, maintained them, and even made them self-sustaining with the help of AI. But now, let's get to a topic that's bound to get interesting. How exactly are humans and AI going to interact in these new societies? I mean, it's one thing for AI to handle logistics and maintenance, But what happens when it becomes a part of our everyday social fabric in space? Now think about this. In our new colonies, AI won't just be a tool we pull out when something breaks. It'll be everywhere, an advisor, a guide, even a friend to some. Imagine waking up in a habitat on Mars, and your AI assistant has already started preparing your day, monitoring your health, and maybe even suggesting what tasks to prioritize based on environmental conditions. Picture this. Your AI assistant doesn't just manage your schedule, it keeps you safe. Say there's a sudden dust storm and you're advised to delay a scheduled task that involves going outside. Or if you're in low gravity, the AI might suggest exercises to keep your muscles and bones strong, making sure you're not just surviving but thriving. And then there's the whole social aspect of it. In these isolated colonies, AI can actually help keep morale high. It might sound far-fetched, but imagine an AI that recognizes when people are stressed, schedules downtime for the crew, or even organizes social activities to keep everyone connected. Loneliness and isolation can be real issues out there, and having AI that recognizes emotional cues could be a game changer. From organizing movie nights to reminding you to take breaks, AI would be essential for the mental and emotional well-being of people in space. Think of it as a supportive friend that's attuned to your needs and knows just when to step in. And with advanced machine learning, AI could adapt its personality over time, becoming more intuitive and even learning the preferences of each person in the colony. But what's interesting is that these AI systems wouldn't just have one setting for everyone. They'd be uniquely tailored to each individual, building relationships in ways we're only starting to imagine. One person might prefer an AI assistant with a serious, task-focused personality, while someone else might want one that's lighthearted and conversational. Imagine if you could customize your AI's tone, humor, and even its hobbies based on your own personality. In a way, each of us would have our own personalized AI companion, growing and evolving with us. These AIs could learn from our daily routines, anticipate our needs, and even make suggestions for how to handle challenging days or low-energy periods. It's not hard to see how an AI could end up feeling like an important part of our lives in space, almost like a family member. And beyond personal connections, AI will play a critical role in team dynamics as well. Think of it as a group facilitator or a mediator. It could help resolve conflicts, reminding everyone of each person's role and strengths, or even suggesting team-building activities. After all, keeping a group of people working harmoniously in a high-stress, enclosed environment for long periods is no small feat. And AI's role in decision-making won't just be limited to small day-to-day tasks. Picture critical moments when a group needs to make a big decision about resources or survival tactics. In these scenarios, AI could serve as a neutral advisor, providing data-driven insights, potential outcomes, and even what-if simulations to help the team weigh their options carefully. But there's more. As AI continues to develop, it'll not only assist but also gradually learn to make judgments that align with our values. Think about how human intuition plays a role in certain decisions. The AI of the future might be designed to mimic some of that intuition, picking up on patterns and making nuanced choices that don't just rely on cold calculations, but take context into account. And this opens up a fascinating question. If AI starts to understand human values and ethical considerations, could it eventually be more than just a helper? Could it become something like a moral compass, a guide, or even a confidant that helps us navigate these uncharted territories in space? As we push further into the universe, it's almost poetic to think about AI evolving alongside us, not just as a tool, but as a trusted partner. With each interaction, each task, each challenge it helps us overcome, we're building a bond with AI that's never been seen before. So we've painted a picture of what it's like to live with AI as our partner out in space. But here's something we can't overlook: AI's role in pushing the boundaries of exploration itself. I mean, we're not just setting up shop on Mars and calling it a day, right? The universe is vast, and the drive to explore is in our DNA. So, how does AI help us reach into the deeper unknown parts of space? Well, one of the biggest challenges in space exploration has always been distance. Even Mars is, on average, about 140 million miles away from Earth. And with each step further out, the communication delays get longer and longer. For a mission to the nearest star, we're talking about years of waiting just for messages to get back and forth. And here's where AI really steps up to the plate. Imagine sending a probe to explore the Proxima Centauri system, over 4 light-years away. With no real-time instructions from Earth, it has to rely on its own onboard AI to make every single decision, from course corrections to managing resources. It's like a lone traveler in the dark, facing the unexpected without any human guidance, constantly learning and adapting along the way. But it's not just about avoiding obstacles. The AI on these probes could also analyze new data on the spot, discovering things that no one on Earth has ever seen before. Imagine an AI detecting signs of water or other chemicals on an unknown moon. It could make the decision to stay a bit longer, gather samples, or even reroute to a nearby planet if it senses something unusual, essentially following its own scientific curiosity. And the AI wouldn't just be our eyes. It would be our brain out there, able to think on its own in real time. By analyzing data, predicting outcomes, and adjusting its mission on the fly, this AI-driven explorer would be able to maximize every opportunity for discovery. Each move it makes would be another step in mapping out the unknown, and it would be constantly feeding that knowledge back to us. And here's where it gets even more fascinating. AI can look at patterns and data in a way that's simply beyond human ability. It can pick up on subtle shifts in gravity, unexpected signals, and even potential alien biosignatures that might be overlooked in a massive data set. It's like having an advanced scout that knows exactly what to look for and has the computational power to process it instantly. Now imagine if it detects something completely unexpected, like a signal that doesn't seem to come from any natural source. This AI would have protocols in place to investigate, sending alerts back to Earth and adjusting its mission to probe deeper. It's the ultimate setup for a groundbreaking discovery. And if anything out there points to signs of alien life, we could trust that the AI wouldn't miss it. But what about when we get even further, to the edges of our solar system and beyond? This is where AI could go one step further, pushing the boundaries of even what we think of as exploration. AI-driven missions could involve sending fleets of autonomous probes, each one designed to cover a different part of a distant star system, coordinating like a cosmic network to gather and share data. Imagine the level of insight we'd gain. These probes could map entire star systems, build three-dimensional models of alien planets, and even test atmospheres to detect elements that might support life. And because each probe is in constant communication with its network, any new data could lead to an immediate re-strategizing. They'd be explorers in the truest sense, reactive, autonomous, and capable of adapting to the unknown. And this isn't just theory. We're already working on the technology to support AI systems that can manage multiple units, like drones and rovers here on Earth. In the future, it's not hard to imagine a swarm of AI drones scouting an asteroid belt or orbiting a planet, each with a unique task but all working together, building a complete picture that we can study back home. These autonomous explorers would essentially be our spacefaring ambassadors, learning as much as possible and sending that knowledge back for us to explore further. And as they keep going, they'd leave a path of relay stations, building a kind of information highway across space that would keep expanding. In a way, it's like laying down the first steps for interstellar highways, connecting far-off star systems back to Earth. And each relay station, each probe, and each bit of data would make our next mission easier and faster, creating an entire infrastructure in space. Imagine having a data pipeline that stretches light years, allowing us to gather and send information across vast distances, creating a bridge between humanity and the stars. And this perhaps is one of AI's greatest potentials in space, not just to be a tool or even a partner, but to become the very structure of exploration itself. AI would be the thread connecting our efforts, the framework holding our reach across the stars. It would be the unbroken chain of knowledge linking us to distant worlds and the guardians of our data highways, making it possible to explore deeper and further than we've ever dreamed. As we've explored the incredible potential of AI in space exploration, we can't overlook the profound implications it has for us as humans. With AI taking on more responsibilities in exploring the cosmos, what does that mean for our role? Are we just passengers on this journey, or do we still have a vital part to play? First, let's think about the training of astronauts. Even as AI takes on many tasks, human presence in space missions remains crucial. Astronauts aren't just there to sit back and watch. They're trained to make split-second decisions, troubleshoot systems, and handle unforeseen challenges. They bring creativity, intuition, and emotional intelligence. Qualities that AI, no matter how advanced, still can't fully replicate. In those moments, the synergy between human ingenuity and AI precision can be a lifesaver. Humans might provide the strategic overview, while AI dives into the details, analyzing potential outcomes. Together, they can navigate through crises that would be impossible for either one to handle alone. It's this partnership that could make all the difference in the harsh environment of space. Let's also consider the emotional aspect of space exploration. Humans crave connection and experience, and our relationships with each other and our environment are vital for long-duration missions. Think about it, space can be isolating and even lonely. How will AI help us cope with the psychological stresses of exploration? Here, AI can play a supportive role, monitoring astronauts' well-being, providing tailored support, or even acting as a conversational partner when things get tough. Imagine an AI that not only helps maintain a spacecraft, but also engages astronauts in dialogue, providing companionship during those long stretches in the void. It's all about humanizing technology to support the human spirit. But there's more to this story. As we delve deeper into AI's capabilities, we find that humans will also need to focus on the ethical implications of our reliance on technology. With AI managing critical aspects of exploration, who holds responsibility for decisions made in space? If an AI system makes a mistake, who's accountable? And how do we ensure that our moral compass is embedded in the AI that guides us? It's a crucial conversation. Our exploration efforts must be guided by ethical frameworks to ensure that we respect the environments we're exploring, avoid contaminating other worlds, and treat any potential life forms we encounter with dignity. The questions we ask today about AI will shape the kind of explorers we become in the future. Furthermore, collaboration between nations will be key. Space exploration is a global endeavor, and as we venture further into the cosmos, sharing knowledge and resources becomes essential. AI can facilitate this collaboration, acting as a bridge that connects scientists and engineers worldwide, pooling data, insights, and innovations for a collective mission. Just think about it. With AI helping us communicate and coordinate on a global scale, we can pool our resources and brainpower like never before. It's about building a community of explorers united by a common goal, understanding our universe, protecting it, and possibly sharing it with others. And here's the exciting part. AI can empower the next generation of explorers. Think of the young minds inspired by the idea of working alongside AI to uncover the mysteries of the universe. As we develop AI that enhances our capabilities, we also cultivate curiosity and innovation in our youth. They will be the ones pushing the boundaries of what's possible, finding new ways to explore beyond our solar system. It's a beautiful cycle. As we advance in AI and space exploration, we inspire others to dream big. We're not just preparing for missions, we're preparing for a future where exploration is a shared human experience enriched by our partnership with technology. AI isn't here to replace us, it's here to amplify our abilities and expand our horizons.